Here we are again, day 4, preliminary review. This is the review for chapter 1, and this is the second part of it. So we're going to focus on solving rational equations, solving equations by substitution, and then we're going to get into some inequalities. Now, some of this material might actually be new, all right, but we're going to break the steps down for you, so hopefully it's not too difficult. All right, so I'm going to go through this relatively quickly. Come to class with questions, okay? So this first one is a rational exponent equation. So we kind of treat this like a square root method equation, or sorry, yeah, square root equation, okay? So the first thing we look at here is we see, okay, we've got this rational exponent, a fraction, okay? So in order to solve this, we need to isolate this portion. I don't see a variable anywhere else, okay? So it's like that square root method. So we're going to isolate this guy. Add 47, divide by 2. So here we are. So now our goal is we need to undo this exponent. So how do we undo this exponent? Well, in order to undo it, we need to raise both sides to the reciprocal power, all right? So I want to raise both sides to the 5/4 power. All right, and by doing so, remember, power of a power we multiply. So going straight across, we would have 4 times 5, which is 20, over 5 times 4, which is 20, which 20 over 20 is just 1. So we get x by itself down here. And now we have 81 to the 5/4. Okay, so now this is where our powers come into play. So this is really telling us to take the 4th root of 81, and then what we're going to do is raise it to the 5th power. Okay, so hopefully we remember that the 4th root of 81 is 3. And now we're going to take 3 and raise it to the 5th power, and we get our final answer. Okay, the next equation is going to be an equation that we're going to solve by substitution. Okay, so if we take a look, we have 4x to the 4th minus 25x squared plus 36 equals 0. So what we want to do is we want to make a substitution to make this a little easier on ourselves. So I can see, all right, well, what if we let this x squared equal a? All right, so if x squared equals a, then that means a squared equals this x to the 4th, okay? So all we're going to do is make a substitution. So I just was able to determine what I wanted it to be, all right? So I'm going to take this and I'm going to make it a linear term, which means this guy becomes a quadratic, all right? So now all I'm dealing with is this 4a squared minus 25a plus 36 equals 0. So we created a quadratic equation. We know how to solve quadratics. Our first goal is to see if we can factor it. Now, I quickly walked through this. You can slow down and pause and take a look at the work. But I use the product sum splitting the middle method to solve for my a values down here. A is 9/4 and a is 4. So now what we need to do, though, is I solved for a. I need to find what x is, all right? Because that's what our equation is originally in. So now what we need to do is we need to go back and substitute, okay? So we know what a is. We need to substitute back so we can solve for what x is, all right? So when a equals 9/4, we're really solving this equation. So how do we get x by itself? Well, we just take the square root of both sides. But when we take the square root of both sides, what do we have to remember? You better tell me plus or minus. So when we take the square root of 9 over 4, square root of 9 is 3, square root of 4 is 2, and we can't forget about the plus or minus. So then over here, when a is 4, we have to find what x is, all right? So again, we set the equation 4 equals x squared, and we take the square root of both sides. And when we take the square root of both sides, we cannot forget plus or minus, okay? And then we have our answers. So remember how we talked about the number of solutions should match the degree of your original equation? Well, how many answers do we have? we have plus or minus 3/2, that's 2, plus or minus 2, that's another 2, for a grand total of 4 answers, 4 solutions. And what was the degree of our original polynomial? It was a degree 4, so that works. Now we're getting into inequalities, and our first inequality we're going to look at are linear inequalities. All right, now these are ones you're probably most familiar with and most comfortable with, but we have to take it one step further than we did last year and write it in interval notation for our answer. All right, so if we zoom in on this first one, all right, hopefully we remember how to solve linear inequalities. So the first thing I did was I distributed this -4, okay? And now I gathered all of my variables on one side. I brought the 20 over to the other side. All right, so in order to get x by itself, we have to divide by -6. But I want you to pay close attention. Remind yourselves what happens when you divide an inequality by a negative. Remember, you have to switch your sign. All right, so if you take a look, our sign switched from greater than or equal to less than or equal to when we divided both sides by -6. All right, we have one last step because we are told to write our answer in interval notation. So I want you to give that a try and then come back and see how you did. Did you get -infinity to 5/6 inclusive, meaning a parenthesis at -infinity and a bracket at 5/6? Moving on to the next inequality. This is a compound inequality where whatever happens to the middle has to go and happen to the outsides as well. So to get x by itself, we subtract 4 from all 3 locations. And now how do we get x by itself here? Well, we can multiply everything by the reciprocal. So I can multiply the middle by 3/2, and then I'll have to multiply this side by 3/2, and then I'll have to multiply this side by 3/2. And by doing so, we get our inequality for our answer. But again, we have to write this in interval notation. So go ahead and do so, and I will do so at the same time, and we'll check back. Okay, so it should be parenthesis -18, comma 9, bracket. Now let's look at absolute value inequalities. So again, this is a review for you, but I laid out the steps very nicely. And we're going to use these guidelines for all the rest of the inequalities that we're going to solve. Okay, so we want to solve this absolute value inequality. The absolute value of 2x plus 5 is greater than 3. Step 1, we always make it an equation. So instead of an inequality, I'm going to make it an equation. And then I'm going to solve that equation for what we call critical points. Okay, we know how to solve absolute value equations. We were just doing that in the last video. All right, so we isolate, we set up our 2 equations, and we get our 2 answers here. Okay, so now the next step is we need to plot these critical points on a number line. All right, and we need to test our regions. So I'm going to scooch on over here. We're going to plot these critical points and test our regions. Now, one thing I want you to note is for our critical points of -4 and -1, why do I have open circles here? So think about why I have open circles, and then I want you to look back at the original inequality and notice that it's strictly greater than, so that's why I have open circles there. So you really have to pay attention going back to our original inequality. Okay? All right, so now we go ahead and we test our regions. So we should notice that there are 3 regions here, a region to the left of -4, a region between -4 and -1, and a region to the right of -1. And when I test points, so I chose -5 in this region, and I plug it back into our original inequality. And when I did that, I got a true statement, so I just marked true. In this region, I plugged in -2. When I plug -2 in for x into our inequality, I get a false statement, so I just mark it F. And then again over here, I plugged 0 in for x, and when I plugged it into the original inequality, I got a true statement. So now the next step we need to do is actually shade our number line, right? So if it's true, I'm going to shade, and I'm going to shade in the true regions. But now we need to state our answer using interval notation. So notice we have two different regions that are shaded. So that tells me right there we're going to have that union notation. So I need to have an inequality or an interval for this piece, and I'll need an interval for this piece. So since I'm going -4 is my boundary on the right, I know I will have a parenthesis there, -4, and I'm going all the way to the left, so I'm going from -infinity to -4, okay? In union with, or is another way to say that. Then, since I have an open circle, I know it's going to be a parenthesis, and then we're -1, and we go on forever, so we're going to positive infinity there. So there is our final answer. -infinity to -4, non-inclusive. In union with, -1 to infinity, non-inclusive. These next two inequalities are new, but the process is the same for absolute value inequalities. So if we just understand that process, then we can handle any inequality that's going to be thrown our way in this chapter. Okay, so the first one we're going to look at is quadratic inequalities. So again, step 1, we make it an equation, all right, and we solve that equation. We know how to solve quadratic equations, and we're going to find our critical points. Okay, then we're going to pick those points and test regions on our graph. And then we'll state our final answer, okay, using interval notation. So as I went through here, step number 1, we make this inequality an equation. We know how to solve a quadratic equation. We can solve by factoring. So when we factor it, x plus 3, x plus 4 equals 0, and we get our critical numbers of -3 and -4. All right? So now I test my regions. I create my number line. I put my -4 and -3 in the proper order. This time, though, I have closed circles on my critical points. Why? Why are those closed circles? Go back to our original inequality. Notice now it's less than or equal to, so that indicates closed circles. All right, so now again, I test my region in the original inequality. All right, so in this region here, I tested -5. So when x is -5, I get a false statement up here. So that's going to be false. In here, I choose, well, I can choose -3.5. And what's going to happen is when I plug that in, I'm going to get a true statement. So I put a t there. Over here, I tested 0. That's a nice, easy one to test because this term goes away, this x squared goes away, and I'm left with 12 is less than or equal to 0, which we know is false. So now if I'm going to graph, I'm going to shade in the true regions, so I shade in between there. But now the last step is we need to write our answer in interval notation. So hopefully we are experts at interval notation now. I've got a closed circle at -4, so I know we've got a bracket at -4. I go to -3, and I've got a closed circle at -3, so we've got another bracket there. This last type of inequality is one that you have not seen before. You've solved rational equations. We did that just the other video, but you didn't ever solve rational inequalities. So there's just one extra step with these guys. Okay, so again, looking at our steps, we find the critical points by solving the equation. So step 1, we make it an equation. Except because it's a rational inequality, or fractions, remember there's another thing that happens with fractions. We can't divide by 0. So there's another hidden critical point that we talk about. And we find that by setting the denominator equal to 0, because the denominator can never equal 0. All right, so we'll talk about how we do that. And then we go through, once we find our critical points, just like before, we test our regions on our graph, and then we state our final answer. So let's look at this first example here with rational inequalities. Okay, we've got x minus 3 over x plus 2 is less than 0. Step 1, as always, we make it an equation and we solve. Okay, so how do I solve this? How do I get this x plus 2 out of the denominator? Well, that just means we multiply both sides by x plus 2. I'm going to put parentheses, x plus 2. And these guys are going to cancel, and 0 times x plus 2 is simply 0. Okay, so we're left with x minus 3 equals 0, and we get x equals 3. Okay, so this is one critical point. Okay, now to determine if this is an open or closed point on my number line, I look back at the original inequality. Okay, so this is less than or equal to. So is that going to be an open or a closed circle? Well, hopefully you say closed. Okay, so I know at x equals 3, we're going to have a closed circle there. All right, so that was one way, or that was the first step to find a critical point. The next step is we have to set our denominator equal to 0 because we can never divide anything by 0. All right, so step number 2, we set the denominator equal to 0. All right. And so x plus 2 equals 0, and we get x equals negative 2. Now, this point is always going to be open on our number line because it can never equal this critical number because that would make our denominator 0. So this critical number is always, always, always open on our number line. Okay? So now we're ready to test our points. Okay? So we test our region. And remember, when we are testing our region, we always go back to the original inequality. Okay? So as I'm looking at this, our original inequality is over here. So over here, I'm going to test when x equals negative 3. When x equals negative 3, I get a negative over a negative when you plug that in, which goes to a positive. Positive can never be greater than 0, so I know it's false there. In this middle section, I let x be 0. So when x equals 0, we're left with negative 3 over 2, which is negative, which will be less than 0. So it's true here. And then over here, I chose when x is 4. When x is 4, I get positive 1 over 6, which is not less than or equal to 0. So it's false there. So where are we going to shade? We're going to shade in between. All right. And now our last step is simply to state our answer with interval notation. So now go ahead, write your answer with interval notation. I'm shading in between, and I see I have an open circle at negative 2, so I have a parenthesis. Negative 2 to 3, and at 3 I have a closed circle, so I have a bracket. I want you to try this next one on your own. Use the guide that I have given you, try it on your own, and then I'll show you the answers, and we can bring any questions we have to class next time we see each other. Okay, so here's what I got. Take a look at it, and if you have any questions, let me know. Have a good night.